Section 12.2 deals with the water that we end up consuming during our daytime. Um, we depend on safe water and uh, we expect safe water. Many places around the world, they don't have that. Um, we know that if we go to a drinking fountain or if we go to the kitchen sink and we pour a glass of water, we have clear, clean water. Um, it doesn't just happen that we have clear, clean water. We work at trying to make sure that it is taken care of, that it's cleaned out. Our government does a lot of testing of water. Um, Chapter 12.2 talks about the concentration of certain um, chemicals in the water. Well, it's kind of gross to think about it, but there are chemicals in our water. There's just so small, a few pieces of it that uh, it's not harmful to us. I know that there's some of the things in our book on page 403. They talk about cyanide in our water. Cyanide's a poison. Um, the government, the EPA, Environmental Protection Agency, um, they set a limit of how much certain chemicals can be in the water, and one of the chemicals is cyanide, and it's a poison. They use it in rat poisoning, but they've said that it's okay to have point 0.2, 2/10 of a part for every million parts of water. So if you think of a million pieces of water, take one of those pieces, break it into 10 pieces, 10 equal pieces. 0.2, two of those pieces would be an acceptable amount of cyanide. So it's not a terribly a large amount. Now, there's mercury. Now, mercury we know is poisonous and it's not good for you, but it is something that ends up in fields and refineries and factories, wastes, and it does end up in the water and in the ground. The EPA has said that it's uh, 2/1000ths of a part per million parts. That's a very small amount. I would prefer not having any of that. But that concentration, how much stuff per million parts, um, the EPA sets a certain amount. Um, Now, how do we get that water into our house? Well, if we're taking it from a well, it's just coming up. You got filters in your water system, and it filters out the larger parts and the chemicals and treats it, and then it comes to your faucet. If you're working from like a city type of thing, um, they pull water from an aquifer or a river or a reservoir or a lake, um, and what they do with it at that point, they send it to a water treatment plant. Well, in that water treatment plant, on page 404 in your book, uh, there's a 6-step thing. The first step, they pull it out of the river, the water source. The second step, they send it through mixers. And what that does is it pulls together the dirt and the bacteria, and they all kind of clump together, and they pull the dirt and bacteria out. Then they flow that water into what they call a clarifying pool. What that does is it takes and pulls out most of the big materials that kind of work through a filtering type of system. Um, and then once they get to that point, then they send the water through like a layer of coal and sand and gravel, which then that pulls out even more of the finer pieces of dust and particles and dirt. And then the water at this point looks clear, clean, looks like you could drink it. They add a chemical called chlorine to it, the same chlorine that you put in pools, but not a a large amount. I mean, you don't want to drink pool water, but um, there's enough that will kill the last bits of bacteria. And then they pump it out into the city, and they usually store it, if you see water towers, it gets pumped into those water towers, and then from that point it gets pumped out into the city. Um, Now, after you've drank it, or after you've showered in it, after you've washed your dishes with it, and it goes down the drain, or you flush the toilet, it goes down the drain, then we have to look at trying to treat it, try to recycle it, try to be able to use it again. And all these sewer pipes from your house will lead to a sewage treatment plant. And at that point, um, they strain out most of the materials that they can, big filters, and they try to strain out all the debris, the sticks that have washed down the drain, or the old macaroni cheese that you put in the garbage disposal or whatever. And they pull that out. They take the sludge away, the stuff that they kind of collect. They take that away, and it can decompose. And then they add chlorine to the water to try to kill out the harmful bacteria. And now that whole first process clears out about half of the pollutants, about half this bad stuff that's in it. Half of it's gone. Now the second step is that they pump extra oxygen into that wastewater. It causes some bacteria to grow, and these bacteria eat a lot of the other excess stuff, the sludge and the oil that are still in the water. Throughout this whole process, more sludge, more junk kind of settles down. Grease is skimmed off the top. If you ever poured grease from you made a hamburger or whatever, and you have all this grease and you pour it in a can or whatever, kind of the grease settles to the top. They clear that out. More chemicals clean the water one more time. They add a little bit more extra chlorine, and then they send it back out into the rivers or the lakes or the reservoirs where they're at, and it's cleaned water and it goes back out. Now, if you don't have city sewer, you have something called a septic tank or a septic system, and what that is all your wastewater empties your house, and it goes into this big concrete either box or cylinder out in your yard. You probably have some sort of stack or something of plastic sticking up out of the ground, maybe about this high or so, to have access to it, or maybe it's a concrete lid on the ground. But what happens there is all the materials go into this big concrete box, and the heavier materials sink to the bottom, the lighter materials float on the top, and eventually that septic system fills up. It's basically, if you want to think of it as just a giant garbage can of all the waste that come out of your house, and with showers and toilets and dishes and dishwasher and anything that goes down a drain, basically. That all settles in, and every once in a while you have to have somebody come in and pump out that material, and then they pull that out, and they take that away to a sewage treatment plant. So that's pretty much how a septic system will work in a house. Now these pollutions, we talk about the water getting polluted. We have to be careful not to pollute it, but there are certain things one's called a point source pollution. That's on page 406. That's an actual thing that we can actually point to it and say, this is the thing that's polluting the water. This is the oil dripping out of my car, or this is the factory that's got a pipe that's throwing raw sewage right out into the river. We can see that. It's called a point source pollution. There's also something called a non-point source pollution. What that is there's not a specific place that it's coming from. It's just kind of coming from all over the place. It's rain causing water to flow over land, which is going to take chemicals that a farmer maybe put on the field, or if you've ever seen people spill gas at a gas station, it's then it rains and then it washes that away into the sewer system. It's not a specific spot. It just kind of happens all over the place. Now, we can try to prevent some of this water pollution. We do a lot of transporting of goods on rivers and on oceans and lakes. We can try to eliminate some of the pollution that happens with the shipping. We have big diesel-powered boats. There are spills. If you've ever been on a lake in a boat, you can kind of see the water's looks like almost kind of rainbow on the top of the water. It's the fuel from the engine, the boat motor, kind of spreading out on top of the surface of the water. So we can try to make an effort to try to stop as much of that as we can. as we can. Just knock my mic over. So industries can try to clean the water better before they send it out. Construction, they can be better at trying to make sure that things aren't getting washed off. They can kind of make sure they can collect their waste products and then dispose of it the right way. Farmers will use pesticides. Farmers will use different chemicals. But there are some farmers that are trying to do it the natural way. Just use whatever nature gives you to raise your cows or your crops, and not using the chemicals. Better for the planet maybe, and better for us as consumers. At home, try to recycle as many things as you can. Try to not throw batteries away. Chemicals, don't pour them down the drain. Here's one of the newer things is medicines. A lot of times people are throwing medicines, old medicines, maybe pain pills or whatever they've had, and they just dump them down the toilet thinking, oh, they'll dissolve. Well, they do dissolve, and they do go into the water system, and those things are hard to filter out. And they're finding certain medicines are showing up in water testing. So that's one of the other things. Weed killers, fertilizers, try not to buy as much and use only what you need. But that's all what section 12.2 is about. It's about how we need water and how we clean water, how we treat it. Society depends on it. We're fortunate enough where we can just go get water anytime we want. There's a TED video out there, and I'll probably show it to you in class, but it's about a man who's invented a thing where even if you're in an area where this water's just dirty, brown, chunk floating in it type of stuff, put it in a water bottle, you pump something 2 or 3 times through a filter, and it's clear drinking water. I'll try to show you that in class sometime. Just remind me someday, and I'll let you know, and then we can watch it, because it's an amazing thing. And it's going to help millions of people around the world, because not everybody has access to nice clean water. So chapter 12, how we treat it. Make sure you look on page 404 and 405. How a septic system works, page 406, and ways that we can prevent water pollution. So that's it.